Hey, this is your Stats Sensei. Good morning. It's Mr. Spencer here, and we're going to do the final chi-squared test of homogeneity. Remember, chi-squared test runs a whole lot like a test of independence, and because we're working with proportions, it's somewhat similar to the goodness of fit, but you're going to have multiple table values and multiple samples. So, scenario 3, one random sample indicates that the number of televisions that American families have is distributed this way. This is the given distribution for the American population as follows. We have a total of 600 families that were sampled. A second random sample. Oh, I have two samples. All right. So if I have two samples and they're asking about a distribution, whether or not that there's a relationship or there's an association, or whether the distribution is different, we must be talking about a chi-squared test of homogeneity. Because two samples is going to be homogeneity. One sample would be independence. So at the 1% significance level, does it appear that the distribution of televisions are the same in the far western United States as the population as a whole? So I need to sit there and go, all right, I have to do a test, and what am I going to put in to the calculator? Well, first off, here's one column of data, and here would be the second column of data. Notice these are the frequencies, so these are the observed values. So in this case, I have 1, 2, 3, 4, 5 rows, and this would be one sample, two samples, so 5 by 2. All right, so let's go ahead and get this in so we can get our expected values. And we do that by going second, then the matrix button right here, edit, and it's a 5 enter, 2 enter, and we can just overwrite. So we ended up with 60 enter, and then over here we had 66. We had 96 and 119. We had 330, and we had 340. We had 66, then we had 60. We had 48, and here we had 15. All right, so we have the data entered. We're going to go ahead and run the test. So second quit, stat test chi-squared, which is letter C. We end up getting a chi-squared value, and we'll write this down. Our chi-squared is 20.46 with a p-value that's 0.0004. Be real careful. If it looks like it's greater than 1, you know it. You got zeros up front. Okay, so let's go look at our matrix and get our expected values. So, and I did that fast. So second matrix, over to edit, and drop down to letter B, and we have 63, 107.5, 335, 63, and 31.5. For the second one, 63, 107.5, 335, and 63 and 31.5. So those are what we expect. All right. So the US and the far west have the same proportion of televisions per household. The US and the far west do not have the same proportion of televisions per household. Okay. So that's that's what we're looking at. Two random samples were given. All right. N is less than 10%, more than 6,000 families in the US, more than 6,000 families in the West. Our expected values, we checked them out. They're all greater than 5, so we're good to go there. This first one will be the first one we show, which will be 60 minus 63 squared divided by 63. And the last one will be 15 minus 31.5. So 60 minus 63 squared over 63. And then 15 minus the 31.5 squared over 35. There's our chi-squared. Our p-value is 0.004. We reject the null. There's sufficient evidence at alpha equal 0.01 to suggest that the US and the far west do not have the same proportion of televisions per household. All right, conclusion, we believe that the US and West do not have the same proportion of TVs per household. All right, the proportions vary. So we rejected the null. All right, thank you for watching, and this concludes chi-square test to homogeneity.